So we are jumping in here, doing our integration by u-substitution. So we're looking at this one, and you're thinking, okay, so I got to find out the inside function. First of all, can you just integrate it? Don't forget that you can still integrate. So don't always go right to this move. You know, you're going to feel like you do this every time because we're doing this section of notes, and every one of these examples is a UDU. But, you know, you don't still have to do it if you can do it the short way. So you look at this and you're saying, all right, so I want to find an inside function for my u. Well, an obvious inside function is 2x. Y equals 2x, and then du would be the derivative of that with dx. Look, you don't have enough to roll into. Look, I could make the 2, no problem. I could bump the 5 out, and I can do a correction to make a 2 in there. But I don't have enough to get rid of. I don't know how to integrate sine of e to the cosine of something else. I don't know how to do that. So this u is not strong enough. This was not the one. Now, usually, note, choose the most complicated inside function to be u. So you're right, 2x is inside, but it's not nearly as complicated as the other inside function here. So I'm going to give you a second, see if you can identify what other function is inside another function. Well, hopefully you saw this isn't really inside anything. That's inside of e to the. So I'm going to now choose u to be cosine of 2x. That means du is going to be, what's the derivative? What's the derivative of cosine is negative sine of 2x times, because this is a chain, times by 2, which equals negative 2 sine of 2x. You got to write that dx every single time. Look, if you're doing Corpy's pattern recognition, this is where I struggled. I tried to do this by pattern recognition at first, and I struggled because I looked at this and I tried to do its derivative in my head, and I struggled with it. Maybe you can do it in your head without. That's awesome. Go for it. But, if you can't, if you're like me, then you would probably need to go on from here. So then I'm going to do a UDU. All right, so I've got the 5's got to go. So let's bump 5 out of the way. Do I have to make any corrections? Yes. I need a negative 2. I don't have a negative 2, so I need a negative 2, which means I need to correct by a negative 2. I'll fix that negative on the bottom in a minute. But I'm trying to build du. So I've got the sine of 2x. I've got the dx. I need a negative 2. So I corrected the negative 2. Now, look, this 5 is out front. The sine of 2x, the dx is all rolled into my du. So my function is going to be e to the, and we already defined u to be cosine of 2x. Look how much simpler that equation, that integral is now, the integrand. So now I can integrate this. I would get negative 5 halves. What's the integral of e to the u? E to the u. I'm going to just go ahead and plug it back in. E to the u, our u is cosine of 2x. Why is that? E to the u plus c, which then we can now clean up. Negative 5 over 2 e to the cosine of 2x plus c. That plus c is a whole point on a free response section. Or multiple choice, but you wouldn't forget it on a multiple choice, I should hope. All right, next up. I'm going to encourage you to try this on your own. I'm going to probably do this one with pattern recognition just so I can practice it a little bit more. But if you want to do it with UDUs, go for it. Pause and give it a try. All right, so like I said, I'm going to try this with pattern recognition, but I still think it's nice to write up what u and du are. All right, so I've got 2x's inside of sine, but I've got, 2x inside of cosine, which is inside of squared, which is inside of a cube root. So the most inside piece would be cosine of 2x. Now this squared, I can merge that. How can I rewrite this? How can I rewrite the cube root of cosine squared of 2x? Well, I can rewrite this as to the 2/3. And I'm going to use that as my actual integrand. This is going to become my u to the 2/3. So the thing that's getting raised to the 2/3 is cosine of 2x. du, all right, the derivative of cosine is negative sine, but there's going to be a change, so that's going to be negative 2 sine of 2x. Why is that not okay, what I just wrote? You need to have your dx there. I'm going to be picky about that. Details. All right, so let's try to do this. I'm going to try this one with pattern recognition. So I'm going to take out any riders. In other words, any constants. So I see a constant of 7. I don't need that 7, so that 7's out front. Times by. This is what we call the rider. It's what Corpy calls the rider. Because it just rides, baby. It rides. Next up, I'll go with yellow, I guess. Do I have any corrections that I need to make? So the 7's out of the picture. The derivative du is down here. I like to have this written so I don't have to try to do it in my head. Corpy does it all in his head, whatever. So I've got the sine of 2x. I've got the dx. I need a negative 2, so I need to correct that with a negative half. So I've created my rider. I've done any corrections. So now I can integrate. I can actually integrate something to the 2/3. The integral of something to the 2/3 is something to the 2/3 would be something to the 5/3. So my something is cosine of 2x to the 5/3. And then I need to divide by 5/3, which ends up flipping and multiplying. Why is this not okay? Plus c. And let's try to clean this all up. What did I start with? This kind of greenish color. So that's 7 over 1. That's 7. That's 21. That's a negative 21. Over 2 times 5 is 10. Times, I'm going to just put it on the side today, cosine of 2x to the 5/3 plus c. If this was pre-calc, I would make you rewrite that as the cube root of to the 5th. But this isn't. I know you guys don't have to. I know you guys could clean it up. And if you can't, don't tell me because it'd make me cry. Also, if this was a free response, you would just stop here. Don't even bother to clean up. But anyway, okay. I'm going to encourage you again. I think you can do this without my help. Try to do part C. Let's see how you did. So I'm still looking for an inside. So 2x is the inside. But it's not going to be good enough. Going back to our first example, if I derive 2x, I just get 2, and it wouldn't take care of these sines and cosines. So I'm going to pick, this is inside of something squared. So I'm going to pick cosine of 2x to be my u again. And I think we've done this enough to see that that's du, I'm sorry. All right, I'm going to try pattern recognition one more time. So, any constants? Yes, 2 is out front. Any corrections? Yes. So I've got the sine of 2x, I've got the dx, I've got those. Check. Check. I need a negative 2, so I need to correct with a negative 1/2. My constants are already out front. Check. So now I've got, this is my u, so I think of this whole chunk as something squared. So what's the integral of something squared? Something cubed over 3. plus c. Yay. Start to clean it up. Oh, see you later. 2 and 2, so I would get negative cosine cubed of 2x over 3 plus c. I'm starting to like pattern recognition already. Told you in the last video that I didn't like it, but I'm starting to like it. Let's see. I'll do this one with a full u to u. Pause, try it on your own, see how far you can get. Looking for my inside function again. So, boy, we got a lot of signs going on here. Sine of something, cosine of something. So it looks like the messiest something is this piece. So that's going to be my outside function. I wonder if there's a way that I can kind of underline that piece. Maybe I'll think of something in the next 10 years. So who's u? My inside function is cosine of 2x. Who's du? Negative 2 sine of x dx. So I would rewrite this. I don't have any constants, so that's nice. So my integral would be, okay, so I got, dang it, lazy. That's sine of 2x dx. I didn't use those parentheses. They threw me, man. They threw me. So let's see, what do I have for my du? I've got the 2x, I've got a 2x, I've got a dx, I've got a dx. I need a negative 2, so I need to correct that with a negative half. So this is taken care of, and this is taken care of. That became du. We already said sine of 2x is u, so this becomes just sine of u du. Something that was super complicated. Now, it's always nice when these sort of u's du's work out, right? If they don't work out, we're up the creek. But all these problems are always set up, so something nice will happen. So negative 1/2. What's the integral of sine? So I think about whose derivative is it. So the derivative of sine is cosine. So the derivative of cosine is negative sine. So this is going to be negative. I don't have the negative, right? Now, if you wanted to lose this negative and just make it cosine, you can. I already put the negative down there. We know that u is cosine of 2x. Not over anything right now. Don't forget your plus c. Negative and negative make a positive, so the answer would be the cosine of 2x over 2 plus c. And if you wanted to write the 1/2 out in front, of course, that's perfectly legal. You could go that route too. Oh boy, you're going to hate this one. And you're going to hate it because it involves, remember the sine of alpha plus or minus beta rules that we put on our unit circle? Yeah, me neither. Well, let's look at it this way. Okay, let's start off with trying to pick the nastiest piece. So if we pick the nastiest piece, it's pretty obvious that the nastiest inside function is this mess. So u, give yourself plenty of room, is cosine squared of x minus sine squared of x. So du, I'm going to do it underneath this time because I think I want to try to go over here. I want to try to show 2 examples on this one, or 2 different ways on this one. All right, so let's try to derive this thing. So this is what type of rule is that? Overall, this is a difference rule, but each individual term of the difference is a what type of rule? This is a chain rule because this is really cosine squared. So this is something squared, so that would be 2 something times the derivative of the something. So remember, maybe I'll actually rewrite it on here. This is cosine squared. This is sine squared, right? So something squared's derivative is 2 something times the derivative of that something. So what's the derivative of cosine? Negative sine. Minus something squared is 2 something. What's the derivative of sine? Cosine. So this becomes negative 2 cosine x sine of x minus 2. Now I'm going to just rearrange this. because I want them to have in the same order, and multiplication is commutative, so I'm allowed to do that. And we end up with negative 4 cosine of x sine of x. You might say, oh, geez, so what, right? That doesn't help us because we still have this mess of sine of 2x. Well, whether you remember or not, you could do, maybe I'll go to the very bottom to do this. Let's do a quick review. Sine of alpha plus or minus beta. Sine starts with sine, switches to cosine. If those things switch, then this stays the same. And then we do the other ones that we haven't done. We've done sine of alpha, so we need cosine of alpha. Cosine of beta, so we need sine of beta. So for this problem, if I replace alpha and beta, if I think of this as 2 sine of x plus x, so then alpha is x and beta is x, which means x and x would be here, x and x would be here. And this is a sum, right? Yeah, so this is a sum. Let's try to clean that up. So therefore, sine of x plus x would be equal to sine of x cosine of x minus, plus cosine of x sine of x. Well, those are like terms, right? The order doesn't matter because I multiply, so this turns out to be 2 sine of x cosine of x. So if I go back up above, 2 sine of x plus x would end up being, now this is a 2 multiplier. You could take it out as a factor if you want to. I'm going to leave it for now. So there's a 2. This becomes 2 sine of x cosine of x. So I have 2 times 2 times, so that would be 4 times sine of x cosine of x. Hey, wait a minute here. That's not so bad. It's not so bad after all. Of course, you'd have to remember. Now look, this you should be able to do, no doubt about it. This, I know, I feel for you. That's a struggle. That's a little bit more complicated. Okay, so let's now try to organize what we have. So I've got 4. Okay, any constants. I'm going to leave. I know I'm going to need it later, but I'm going to take it out right now. So any constants, yes, I got 4 and I've got 3. So that's, pick a better color. So I'm going to take out the 4 and I'm going to take out the 3. 4/3 integral, or do I have any corrections? And let's do that. Let's look for corrections. Do we have any corrections? So I need a negative 4. I need a negative 4. Remember, I took this out. So that 4 is not there. That's why I was kind of struggling with what I wanted to do there. So I'm going to take out that 4 here. That means I need a negative 4. That means I need a negative 1/4. So if you wanted to leave the 4 in there, you could just, it's going to end up canceling out. You could just put the negative in there. The integral of, okay, so the 4, the sine x, cosine x, and the dx all rolled into my du. Cosine x minus cosine squared x minus sine squared x is my u. So this is underneath a 5th root that's on the bottom. So when I bump it to the top, it's going to become negative 1/5. So this is something that I can now integrate. I'm just going to make that negative 1/3, have those 4's cancel out. Multiplied by u to the, add 5/5. That would be 4/5. Flip and multiply. Don't forget your plus c. And now we would get our final answer of negative 5/12 times, what did we say u was? Cosine squared x minus sine squared x to the 4/5. I don't like that 4/5, but it's going to have to do, plus my constant. Notice, as soon as I integrate, I throw a plus c in there. You must include that. You can't just put it in at the very end. You have to put it in through all of your work. They won't give you the point if you don't. Pretty nasty, pretty nasty. And obvious question to me is, if I was a kid, I'd be like, how am I supposed to remember that? And that's tough. I don't know. I don't know how to. I mean, I know how I remember it because I teach this class. I teach pre-calc, and so I've seen it 100 times. For you, it takes more studying, or might be one of those that you just bail on when it comes to the actual test. This would not be a free response. They would not expect you. I don't think. I shouldn't say they never would, but I very much doubt they would make you try to do that on a multiple choice. Sorry, not on a multiple choice. All right, I like this one just because there's a couple different ways to do this. So 2x, let's say again, your instincts was to say, okay, my inside function, actually the only inside function right now is 2x. That means du would be 2 dx. Well, that doesn't help me because I don't know the integral of sine u cosine u. I don't know the integral of that, so I'm still stuck. So that's not going to actually save the day. Sometimes you pick a u and a du and it doesn't work out and you got to go pick something else. So let's try something else. Well, I noticed that cosine's derivative is sine, but I also noticed that sine's derivative is cosine. So if I pick this to be u, this could roll into my du. If I pick this to be u, this could roll into my du. And I'm going to show you that it turns out to be correct either way. So the answers don't look the same, but you could pick either one to be your u. So I'm going to pick my u to be sine of 2x. Now I'm going to squeeze this work in because I'm going to try to do it again over here. And then du, derivative of sine is cosine, multiplied by, I've got a chain, so this would be 2 cosine of 2x. I'm going to try to do this with pattern recognition. Do I have any constants? Yes. Do I have any corrections? Okay, I've got, that's the constant, it's gone. The 2x is going to become, that's my u. Cosine of 2x and dx is going to roll into my du, but I need a 2. So I need a correction of 1/2. So look, my function, my u, this whole thing became u. So what's the integral of u? U squared over 2 plus c. So then I can clean this up. I would get 11/4. What did we say u was? Sine squared of 2x plus c. Well, let's try it the other way. Let's say that you decided that you wanted to choose u to be cosine of 2x. So then du, what's the derivative of cosine? Negative sine, but then I've got a change, so it's going to be negative 2 sine of 2x. I'm going to try pattern recognition again. So do I have any constants? Yes, 11's a constant. Do I have any corrections? So this time, this is going to become my u. So I need a sine of 2x. I did it twice. I missed it on both of these. Man, that's a silly point to give up. Man, what? I did it over here too. Why didn't you guys correct me? Why didn't you say something? Jeez. Thanks a lot. Look at the other ones. Did I get the? Okay, I got all the other ones. Okay, so any corrections? So I've got my 2x, my sine of 2x, and my dx is going to roll into a du, but I need a negative 2, so I need to correct that with a negative 1/2. My u is cosine of 2x, so what's the integral of u? Is u squared over 2. Don't forget your constant. So I would get negative 11/4 cosine squared of 2x plus c. Now wait a minute, you might say, whoa, both of those are correct? Both of those? Yeah. Look, we're saying that these two functions, all we're saying is that we're not saying these two functions are the same. We're saying these two functions have what? The same derivative. Now that happens all the time. I mean, we've done this. This was the first thing we talked about when we did derivatives. What's y prime? What's y prime? What's y prime? Right? You know what I mean? All those derivatives, they all have the same derivative of y prime equals 2x. So when I'm integrating, yeah, I can integrate and get different answers, especially when I don't have a defined interval, especially when I don't have a definite integral. I said defined, definite integral. All right, so this is kind of like, this is a good lead-in from here where you had to kind of pick, you had to decide which one you wanted to be your u, and there's two ways to do it. So there's two ways to do this one as well. So I'm going to encourage you to take a minute and try to pick one of your u's and try to go from there. So there's two ways to think about this, and I don't know which way you thought about it first. So I'm going to write up both kind of setups, and then we'll talk about what they are. One method is to leave this as secant squared x tangent of x dx. And then the other method is to write this as the integral of secant of x, tangent of x. So in other words, I took the secant squared and I broke it into two pieces. Now the difference here is, look, you're always trying to find something, some piece that when you derive it, some u that when you find du, it's part of the equation. Sorry, part of the integrand. So in this case, which one of these, when I derive it, would give me the other one? Well, let's start with this. This is something squared. If I pick u to be secant, what's the derivative of secant? You better have it memorized. If you don't, pause it and go somewhere and write it on a piece of paper. Practice those. Derivative of secant is secant and tangent, but we don't have an extra secant. Remember, secant became u. So when I pick this to be u, I would get secant tangent, but I don't have any more secants to merge with that tangent. Ooh, I don't even have an x on that tangent. Why didn't you say something? Okay, so let's pick then. Let's go the other direction. Let's say that u is tangent of x. That means du, what's the derivative of tangent of x? Secant squared of x, and life is a lot better now because now I have that hidden in here. So I'm going to try this by pattern recognition. Do we have any constants? No. Do we have any corrections? No, because I've got my secant squared and my dx. That's going to make my du. So what's my actual integrand? This is u. So I'm integrating u. What's the integral of u is u squared over 2 plus c, which now I can plug back in what u was, and we get tangent squared x over 2 plus c. Let's try the other direction. Over here, you've got to pick a u so that when you derive it, you still have stuff in the function. So when I pick, let's pick tangent again, I need, well, no, I don't want to pick tangent again because it'd be the same problem. So obviously I have to pick secant. But that's okay because what's the derivative of secant? Secant x tangent x dx. So now this stuff, all that is going to become du, and this is going to become u. So I'm now integrating u du. The integral of u du is u squared over 2 plus c. I could put this back in here and I get secant squared x over 2 plus c. Oh, geez, sorry. So at the end, we wanted to show that we could evaluate this, and then the end says, show that these antiderivatives are equivalent but for a constant. I'm not going to go too deeply into this. I think the quickest way to kind of explain it is to just remind you. Remember that there was is there a relationship, one of our Pythagorean identities, between tangent squared and secant squared? Hopefully you remember that there is one. If you can't remember what it is, here's how you remember it. Go over to the corner of your paper, write down the one that you know. Everybody should know one of the Pythagorean identities. Which one is it? Sine squared plus cosine squared equals 1. That's the one that I know. Now, if I want to get the other ones, I just try to think about the one that I want to build, because they all build off of this. I want the one that has tangents and secants in it. Well, what do you know about tangent? Tangent is sine over cosine. So I've got my sine. What do I want to divide this whole thing by? If I want to get a tangent, I need to divide it by cosine. Now, squared, of course, because I need tangent squared, which then means, so sine squared over cosine squared is tangent squared. Cosine over cosine is 1. 1 over cosine is secant squared. So, look, how different are these two sides of this equation? They're only off by plus 1, which is a constant. So I just have to roll some number in here and some number in here to make those two things equivalent. I wouldn't expect you to know how to do that. I mean, it's not worth it. They'd have to, actually, none of us could do it. We'd have to have more information to be able to finish that off. Okay, what are we up to now? Let's just do these last two and we'll call this video good. Seems like a nice stopping before we get into our trig. Oh boy. Evaluate this mess. I'm going to do this one with UDUs. I think it's a little too complicated for me to do. I probably could. I mean, I'm pretty good, but we'll see. All right, so anyway, U. U is my inside function, and it's always the messiest inside function, so the nastiest piece. So I've got a lot of stuff inside, but it looks like, this, I think this is the nastiest piece. Even though this is inside of the 5 to the, I don't know the integral of secant squared of 5 to the something. So I'm going to take this whole chunk and make that U. 5 to the x cubed plus 7. So du then is equal to, oh boy. Now remember, these are always, when you got a base other than e, they start off just like e does. So e to the something is e to the something. So 5 to the something is 5 to the something times natural log of that base. Times, okay, let's just stop there for a sec. Why don't we need to write this with e? Because when I do natural log of e, it's natural log of e to the 1. Those natural log and e cancels, and we're left with 1, so that piece doesn't matter. But why did I put another times in there? All I've done so far is the derivative of 5 to the something. I still need to derive this something. Am I going to need parentheses? No, because that's a constant. So this would be what, 3x squared? Okay, so let's see. I'm going to try to do this with, all right, I told you I'd do it with UDU. I'll stick with that, and then I'll do the next one with pattern. So let's see. Any constants in here? 4 is a constant. That's got to go out. The integral of. Okay, so 4 is out of there. I need to build a du. So I need a 5x. Got that. I need a natural log of 5. I don't have that. So I need to create a natural log. I need to correct a natural log of 5. I need a 3x squared. I've got the x squared, but I don't have the 3, so I need to correct that. So I also need a 3 out there. And then my actual function, this is what u was, so then this would be the integral of secant squared of u. All of this, dang it. What did I forget? Nobody told me. My dx when I did my du. All right, so in my du, to make my du, I need a 5 to the x cubed plus 7. Boom, got it. I need a natural log of 5. I don't have it. It's a constant, though. It's just some number. I don't know what the number is, but I know it's a number. So I need to correct that number. I already took the constant out. I need a 3x squared. I've got the x squared, but I need a 3, so I need to correct that. And then I need a dx, and I've got that. I've got my u, I've got my secant, and then I need my du. So we can now integrate this. 4 over 3 natural log of 5. What's the integral of secant squared? That's tangent. And I'm going to just put u back in there. 5 to the x cubed plus 7. Why is this still wrong? These are indefinite integrals. I would not want to try to find a definite integral without being able to use my calculator. Okay, pause. Try it on your own. See if you can do it. Let's see how you did. So I'm going to do pattern recognition, but for me, at least for now, I need to still write out u du's. So who's inside? That's nothing inside. That's inside, but its derivative is not enough to account for everything else. E to the something, that's got to be my most complicated inside function. So then du, all right, so see if we can do this in our head. The derivative of cosine is negative sine, but I'm going to have a chain in there, so there's going to be a 15x squared before the sine. And I almost forgot my dx. Now look, let's say you couldn't do all that in your head. Then do it the long way. You should still end up at the same place. That's why you have the power of the pause button. So now I'm going to try to do this with pattern recognition. Is there anything that's a constant? Yes, my only constant is 22. There's my rider, as Corpy calls them. Do I have any corrections to make? Let's see. Sine of 5x cubed, check. Dx, check. X squared, check. But I need a negative 15, so I need a correction there of negative 1 over 15 times, and now I'm going to do the actual integral of e to the something. So e to the something is e to the something. Can it really be that easy? Plus c. Let's clean it up. Negative 22 over 15. E to the. So we're going to move on after this to a spot where integration just has to come natural to you. So this ability, kind of like in the first semester, by the end of the first semester, doing derivatives was not something that you should have taken a long time to think about. You should just be able to do a derivative fairly quickly. And that's where you're going to get this practice in on the homework set, is just knowing how to do a derivative and an integral. The more practice, the better you're going to get at those things.